Hello friends, welcome to Shiksharthi. In this video, we shall be discussing trigonometry. So let's start. So if you recall my earlier video on trigonometry, which was the first part, now in this part, we'll be discussing more or less the same things as we had talked about. Right? What had we talked about? We had talked about trigonometric ratios, we had talked about trigonometric identities. Thereafter, we had finally talked about the complementary angle concept. Right? So, in this video, we'll be taking it to a next level. So, let's make the learning fantastic. Okay? Now, we are taking the same triangle as we had taken. So, we are taking a right angle triangle, and in this right angle triangle, the angle Y here is 90 degrees, followed by angle X and angle Z, which are lesser than 90 degrees. So, in this case, which triangle are we taking? We are taking an acute angle triangle. So, we are taking an acute angle triangle. I repeat, we have taken a right angle triangle, and in this right angle triangle, all the angles except for angle Y. Angle Y here is 90 degrees, which is where the right angle is being formed. So let's understand it like this. Okay, this is the perpendicular side that we are talking about. This is the base. This marker is the base, and now the vertex of this perpendicular side. So if we talk about the vertex, here is the tip of this finger, which is X. Then we are getting a right angle here. Now this right angle is Y, this is vertex Y, and then the third vertex here we are taking it as Z. So thereafter the triangle that is being formed is a kind of this triangle that we have already formed. So this is an acute angle triangle because the angle X and the angle Y that we are talking about, both of these angles are lesser than 90 degrees. So when you are finding out trigonometric ratios, you will basically come across two varieties of trigonometric ratios, in which the first variety here would be an acute angle triangle, and the second variety here will be an obtuse angle triangle. Now what is an obtuse angle? An angle which is greater than 90 degrees. Okay, so here the acute angle triangle that you are getting here is, you are having two acute angles here, followed by 190 degrees is what we are getting. You are getting two acute angles, and you are getting one right angle is what we are taking here. And in this case, if I get an obtuse angle triangle, one angle will be an obtuse angle. Obtuse. O is for obtuse, R is for right angle, and A is for acute. And the remaining two angles will be always acute. Why does this happen? This happens because the sum of all the interior angles of a triangle is equal to 180 degrees. So if I take one angle which is greater than 90 degrees, for example, if I take one angle as 91, in that case the sum of the remaining two angles become equal to 89 degrees. The sum of two angles. Now when sum of two angles becomes equal to 89 degrees itself is an acute angle which is lesser than 90 degrees. Now their sum will also be, so individually also there will be acute angle triangles. Okay, so these are two cases that can be formed. There are other cases also that we can form. We can take a totally acute angle triangle. So when I take a totally acute angle triangle, for example, if I take a triangle like an equilateral triangle, in an equilateral triangle, you will get all the three angles of an equilateral triangle as acute angles only. I hope you are aware of this, right? So while forming a triangle, you can form only three different types of triangles. And why are we talking about triangles here? Because we are taking trigonometry to the next level. Now when we are taking trigonometry to the next level, what are the chapters which are important here? So one is, we are talking about triangles, which is geometry. The other is coordinate geometry, and the third chapter which is important here is quadratic equation. Now why do we take it as a quadratic equation here? Why is it important? Because we know that we are supposed to apply a Pythagoras theorem here. So Pythagoras theorem itself is, we know what is a Pythagoras theorem. We know that p square plus b square is equal to h square. We already know this. So let's say the third thing that we are talking about here is the Pythagoras Theorem. So which is p square plus b square is equal to an h square. So this is a kind of a quadratic equation only. And we'll talk about this in detail in the next few minutes. Okay. So if you recall, in the first video itself, we had talked about a 3 into a 3 square. Though I did not talk about that like this, but now since we are taking it to a next level, so let us say, why do I call it as a 3 into 3? And remember the PBH rule. So now I am calling it as a 3 into 3 square. Now when I say 3 into 3, please understand it like this. This is numerator into a denominator. A 3 into 3 square. Where numerator will take 3 values. Similarly, the denominator will also take 3 values, which is why you got those 9 values which we had talked about in the first video. If you have not seen the first video, this makes you a point to watch my first video on trigonometry. Right? Okay. Now, what are we going to discuss here? Discuss more or less the same, but as we know that we are taking it to our next level, and we are going to make this learning really fantastic is what our aim is. So let's enjoy. So I know that p by p is equal to a 1, same here, same here. And we know now if I have to complete this first column, so I know p by b is what? Tangent theta, which we call it as tan theta. Let's say tan theta degrees. Okay. Now instead of calling it as tan theta, we know it is tan theta. Now I'm substituting the value of theta here because we are taking it to a next level. So in that case, this becomes tan z. Right? Now when I'm saying this is tan z, now if I complete this, and we know that now p by b, if I take this diagonal of the square, we know along the diagonal we are getting a 1 only, right? Now let us talk about other diagonals. So now I am talking about the other diagonal. The other diagonal is this. This is the other diagonal, which is the longest diagonal in a square. So this is the longest diagonal in a square, so is this diagonal. So how much is p by h? So perpendicular divided by the hypotenuse gives me sine z. Right? So now let's see the diagonal side of it. So we know that p by h and h by p are reciprocals to each other. So in that case, what is the reciprocal for sine? Cosec, which we know the full form of cosec is cosecant. So let's say this is cosec z. So we have completed both the diagonal parts. Now let us talk about the remaining values. So the remaining values are these. So let's talk about now p by b and b by p are reciprocals to each other. Mark the word being used. I'm using reciprocal. I'm not asking you to take the inverse of this. There is a difference between taking the reciprocal and the inverse. So reciprocal may or may not be equal to its inverse. For the time being, we'll take it as reciprocal is not equal to its inverse. Because when I say may or may not be equal, so there are cases wherein the reciprocal may be equal to its inverse. There are cases wherein reciprocal may not be equal to its inverse. Now, this we are not discussing it in detail because maybe this has nothing to do with the discussion that we are doing as of now. As of now, we just need to understand that we will call these things as these are reciprocals to each other, these are reciprocals to each other. So we know that cotangent, which is known as cot, this I can say this is cot z. At the same time, now base by hypotenuse. How much is base by hypotenuse? Base by hypotenuse is known as cos or cosine. Now cosine is a full form. The short form here is cos. We'll be using the short form here. So this I'll call it as cos z. And now along this diagonal. So along this diagonals, these were reciprocals. Along these diagonals, you're again getting the reciprocal values. Now when you're getting the reciprocal here, we know that the reciprocal for cosecant is secant. the short form of which is sec. So blindly you can say it is sec z. So everywhere, so if I know if I'm talking about tan z and its reciprocal, then it will be cot z. If I'm talking about sin z and its reciprocal, cosec z. If I'm talking about cos z and its reciprocal, it will be cos and sec z. Once this thing is complete, now this we had already discussed in the first video. The only thing that we are doing here is we'll associate it with something that we had talked about. So complementary angles is what we are going to associate this with. Now we know that perpendicular upon base is this, right? So now if I take, is there any other value that I can take here which gives me perpendicular upon base only? So if I take this value, now if I say this angle, which is, and if I take it as cot x, now cot is upon the perpendicular, so I can simply say that this can also be termed as cot x. And the moment I get there, here, then I take the reciprocal here, which I can say this is nothing but tan x. Right? The same thing now you can do here. So the moment I say sin z, so can I say cos x? Now cos x is base, which is p, upon hypotenuse, which is h. So can I say this is cos x? Yes. The moment I get this, I should be able to get this even. So what is the reciprocal for cos? We know that the reciprocal for cos is sec. So can I say this can also be written as sec z, sec x? Of course. Right? Similarly, now cos z is equal to base upon hypotenuse. Now when I am taking sin x, now sin x is nothing but just like saying perpendicular upon base, perpendicular upon hypotenuse. So can I say this is sin x? Of course. And the moment you were able to say this, and you know that along this diagonal which is a 2 into 2 square, along this diagonal we are getting the reciprocals. So what is the reciprocal for sine? So the reciprocal for sine is cosec. So can I say this will be nothing but cosec and then blindly x? What are you getting from here? You are getting now these things will hold good only when x plus z is equal to a 90 degrees. So we are basically talking about the first case. Which first case are we talking about? We are talking about an acute angle triangle. Though to be more precise here, we are talking about a right angle triangle. So in this case, now we are talking about a right angle triangle in which one angle is right angle and the other two angles are acute angle each. In that case, these will hold good. So we are talking about complementary angles, complements of each other. So x and z are complements of each other, is what we are talking about. Okay, so now why did we talk about this? We talked about this because we had established something. What had we established? We had established that sine square x plus cos square x is equal to a 1. If you recall, we had established this. It was just like saying that this square plus this square is equal to this. So the first column square plus the second column square gives me equal to 1. So that is how we had established the three identities. Now once I know this, I can establish something else also here. What is something else that I can establish here? I know that sine x is equal to cos z. So the same property can be written given this condition. Which condition? That x and z are complementary to each other. So I can say sine square x plus cos square x is equal to 1. Similarly, I can say sine square z plus cos square z is equal to 1. Now, if you fail to understand this, you can always substitute the values, because PBH, please remember, please be here. Please be here. I mean, perpendicular base and hypotenuse. So please remember, if you fail to understand this, you can always substitute the values and get to the correct answer as advised. So whenever you are getting any question on trigonometry, I mean, just use the concept of PBH. So for example, if you were given this to be proved by you, what will you do? You will simply use PBH. How much is sine z? So you'll say p square by h square is what you're going to say. Plus how much is cos z is b square by h square. And we know p square plus b square is equal to h square. So h square divided by h square gives me a 1. Right? So have I written this correctly? Of course. Okay, moving on. In how many other ways I can use the same? So what I could have done was I could have changed both, or I can change one of them. So I know that let sine square x remain the same and cos x can be written as sine z. Similarly, I can let cos square x remain the same and convert sine x into cos z. And thereafter you can always check whether all these are written correctly or not. What is your objective? You will get questions on these. Right? So can we say in the similar manner the remaining two identities that we had established, the remaining two. Which were the remaining two identities? You could have said tan squared z plus 1 is equal to sec squared z. Right? Or you could have said 1 plus cot squared z is equal to cosec squared z. Using the same logic that we have used here, can we make 4? Can we convert 1 into all those 4? Yes, you can. And please take it as an assignment so that you can convert it. And when you convert it, you will learn something from it. So this is an assignment that I have given to you. Having said this, now let us talk about the PBH concept in detail. And now we will make you understand this with the help of quadrants. That means we are going to introduce the concept of coordinate geometry, which we had introduced, which I had introduced in the very first session also. But here it makes sense. Now what makes sense? Now if I say A here and if I say sine here, we are talking about the first quadrant. Second quadrant S. Third quadrant T. Fourth quadrant C. All you need to remember here is what is ASTC. So the best way to remember is associate something really interesting with the real life scenario. And since all of us are students and we are preparing for let's say some topics or competitive exams, or maybe board exams or school exams or any kind of a testing, or maybe any kind of a learning. We are not looking for any testing. We are just looking for learning as of now. So in that case, all students take care. All A, students S, take T, care. Especially when you are learning something. Now what are we talking about? We are talking about all of these. We are talking about all trigonometric ratios. How many trigonometric ratios have we talked about? We have talked about sine, reciprocal of sine, which is cosec. We talked about cos, reciprocal of cos, sec. We talked about tan and reciprocal of tan, which is cot. So how many ratios have we talked about? We have talked about 6 ratios. Okay. So all of those 6 ratios are positive in the first quadrant. Now when you say all of them are positive in the first quadrant, that means when you are writing it in the form of a numerator divided by a denominator, both the values, when divided, will give me plus only. Similarly, when we talk about the second quadrant, now second quadrant only sine would be positive. In the first quadrant, all of them would be positive. In the second quadrant, only sine would be positive. In the third quadrant, only tan would be positive, and in the fourth quadrant, only cos would be positive. And the best way to remember is just with the help of their initial. Initial is ASTC. All students take care. So all sine, tan, cos. All the 6 trigonometric ratios are positive in the first quadrant. Only sine is positive in the second quadrant. only tan is positive in the third quadrant, the remaining are negative. So here 6 are positive and 0 are negative. Here only one, that is sine, is positive, but if sine is positive, its reciprocal will also be positive. So here 2 of them are positive and 4 of them are negative. Okay. Similarly, if I say tan here is positive, cot will also be positive. So in that case, 2 of them are positive here, which is tan and cot. And then remaining 4 are negative. And here if cos is positive, so would be sec. And then 4 are negative. This is one side of it. Either you remember this, or you use alternatively, you use the PBH concept. So how do I use the PBH concept? Now, please understand it like this and be very, very attentive. And it is just once that you need to understand. Second time it becomes just like a cakewalk for you. Right? It becomes very, very easy for you. How? Write PBH. And this we are talking about. Now this was an alternative discussion. So either I do it like this and understand these two things, or I do it like this with the help of these two things. These two things we are talking about angles. So before I go on this, first quadrant means we are talking about a acute angle or a right angle. Right? Second quadrant means we are basically talking about obtuse angle, or we are talking about a straight line which is 180 degrees. Third quadrant is we are talking about reflex angle. So any angle between 180 degrees to a 270 degrees or equal to a 270 degrees is what we are talking about. And the fourth quadrant, we are talking about the reflex angle, or we are talking about a circle. So when we are talking about a reflex angle, we are basically talking about x will be theta being greater than 270 degrees. This is 270. Lesser than 360 degrees, or it becomes equal to a 360 degrees is what we are talking about. Please remember this. So when we are talking about these, we talk about this, or alternatively we talk about the PBH concept, in which we do not need to memorize this. Okay, let us see how. So what I am suggesting here is start from plus plus, assign values like plus plus to PB, then keep plus as constant for P, and the next one becomes minus. Then take negative negative for both, and then take negative, let minus be constant here, and then take plus here. I repeat, just focus on P. So there are two cases wherein P will take positive values. Thereafter you will take two cases wherein P is taking negative values, two negative values. Now in the first case, B will also take a positive followed by negative. In the second case, negative followed by a positive is what I am asking you to do. Now in this, all these cases take the value of H as positive. Now once you have done this, now what you are expected to do is just take the opposite signs of this. So what is the opposite sign for plus? Minus, here minus, here minus, here minus, plus minus. Just take the opposite signs or opposite polarity. Plus, plus, minus, and here you will take it as plus, minus, minus. Once you have done this, you have divided the entire discussion into 8 things in all the quadrants. So now what are we saying? If PBH, all the 3 are positive or all the 3 are negative, we are talking about the first quadrant only. Or we are talking about the second quadrant wherein they are alternatively positive or negative. Alternately. So if I start with positive, they are alternately positive. If I start with negative, they are alternately negative. Here we are talking about minus minus followed by a plus, and then plus plus followed by an opposite polarity. Here we are talking about minus followed by the same polarities and plus followed by 2 opposite polarities is what we are talking about. This is just like another way to understand this is, we can introduce a concept of probability. You're tossing a coin, you're having 3 outcomes, and then how many times are you getting a head or you're getting a tail? How many cases will you make? You will make 8 cases since you have already done probability. Right? You can associate. Next way to associate here is, we talked about quadratic equation. So this is just like saying, why are we making this case here? What is minus whole square? Minus whole square gives me positive only. What is minus whole square? It gives me positive only. Similarly, what is minus whole square? It gives me positive only. So positive plus positive gives me positive. The same reasoning I can do for all these cases if I were to understand it in a better manner. And at this level, this is the best way in which you can understand. If I were to take it to a higher level, I can always say y-axis, x-axis and z-axis. Is what I am talking about, y-axis, x-axis or z-axis. But that is slightly out of scope as of now, so I have not introduced that concept, but in a certain way I have already told it to you. Now the next point which arises after this is how to use this is equally important. So how to use this is what we are going to see now. So let us say I am picking up an example from your book, which is example 1, which says tan A is 4/3. Now if tan A is given as 4/3 and if I am interested in knowing the values of all the trigonometric ratios, let us see how to do it. So we know that tan is equal to, so convert it into PBH. Now when you are converting it into a PBH, please remember, since you are taking positive plus 4 followed by plus 3, so we are talking about PBH. We are talking about PBH. Please remember that. So we are talking about PBH. So now in this case, when we had taken two positive values, so we are basically talking about first quadrant, right? So in that case, we will take two negative values as well. Okay. So now if I take 4/3 in this case, this can be either plus 5 or this can be minus 5, keeping these constant. So here we were talking about this, which is first quadrant, but at the same time we talked about this can be treated as a quadratic equation. How? Now we know that p square plus b square is equal to an h square. So what is the value of p? 4 square plus b square, which is 3 square, gives me h square. So we get the value of h square is equal to how much? 25. Now the moment you say h square is equal to a 25, you will say that h square minus 5 square is equal to a 0, which is just like saying h is equal to plus 5 or minus 5. So please recall, why had we talked about all these 8 cases was, if I am taking the values of p as positive, p and b as positive, in that case the value of h could be positive along with plus, plus, minus. So you'll talk about this case. So the point that I'm trying to make here is, when it is said that tan A is equal to 4/3 and it is not given in the question whether A is an acute angle, you can't assume it from your side. So you got one case wherein the value of A would have been there in the first quadrant, and the second case that you're getting here is the value of A could have been in the second quadrant. Why is this happening? This is happening because P and B, both of them are positive only in the first and the third quadrant for tan. This is one perspective. Another perspective is, you already know that tan theta is positive in the first and the third quadrant. So either, as I had discussed earlier. So what had I discussed? I had discussed, and please make a fun, enjoy it. Just enjoy out of this exercise. So now when I say tan theta is positive, right? So either it falls in the first quadrant or it falls in the second quadrant. Either I can understand it with the help of this concept that was discussed, or I talk about the PBH concept. Now PBH concept helps me to put all these values here, which is why you were advised to subscribe to the PBH concept. I hope you learned something in this video, and if you feel that this video is really informative, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on some specific topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, Goodbye.